Integrating a generator into a system with parallel feeds requires careful planning and execution to ensure safety and compliance with the electrical codes. The situation described involves two 200-amp feeds running underground to a trough, which then splits to feed two separate 200-amp main breaker panels. A 25 kilowatt generator is to be installed, and space is limited. The suggested approach is to use a 125-amp breaker disconnect for one of the feeds and a transfer switch, while also moving some loads to the other panel. Here's a breakdown of the considerations and steps involved. Firstly, assess the existing electrical system. The parallel 200-amp feed suggests a substantial service capacity, likely intended to handle a significant load. Verify the actual load on each panel. A load of 45 amps on one panel is relatively light, but it's crucial to confirm this with a load calculation. This calculation should include all continuous and non-continuous loads, accounting for demand factors where applicable. Secondly, consider the generator capacity. A 25 kilowatt generator at 240 volt single phase can supply approximately 104 amps. This is calculated by dividing the power in watts, which is 25,000, by the voltage, which is 240 volts, which results in 104.166 amps. Ensure that the generator's capacity is adequate to cover the essential loads you intend to power during an outage. Thirdly, address the transfer switch and disconnect. Using a 125 amp breaker disconnect for the generator feed can be a viable solution, provided it's properly coordinated with the generator's breaker and the load requirements. The transfer switch will allow you to switch between the utility power and the generator power safely. Fourthly, plan for the proposed wiring changes. Removing the 200 amp breaker in one panel and feeding the panel through the generator via the 125 amp disconnect requires careful consideration of overcurrent protection. The intention is that the 125 amp generator breaker and the new 125 amp disconnect will protect the panel. Fifthly, assess the protection and coordination. The 125 amp breaker protecting the generator needs to be properly sized and coordinated with the generator's output. The 125 amp disconnect also needs to be appropriately rated for the load and the available fault current. Verify that the conductors from the 125 amp disconnect to the panel's main lugs are sized appropriately for 125 amps according to the National Electrical Code. On NEC Table 310.16, taking into account the conductor type and installation method. Sixthly, handle the load balancing. Moving air conditioning units to the other panel helps balance the load between the two panels. Conduct a thorough load analysis to determine the new load on each panel, ensuring neither exceeds the panel's rating nor the capacity of the respective feed. Seventhly, implement safety measures. Install the generator with appropriate safety measures, including proper grounding, ventilation, and protection from the elements. The generator should have a dedicated grounding electrode system as required by the NEC. Eighthly, review the NEC compliance. The entire installation must comply with the NEC and local electrical codes. This includes requirements for conductor sizing, overcurrent protection, grounding, bonding, and wiring methods. Ninthly, consider the main lug adaptation. Connecting the 125 amp feed to the main lugs of the panel that formerly had a 200 amp breaker is generally acceptable, as the lugs are rated to handle the current. However, ensure the lugs are in good condition and properly tightened. Tenthly, account for the short circuit current rating. Verify that the panel's short circuit current rating is adequate for the available fault current at the service. The generator's output impedance will typically limit the fault current, but it's still important to verify. 11thly, test the system. After completing the installation, thoroughly test the system to ensure it functions correctly and safely. This includes testing the transfer switch, the generator's output voltage and frequency, and the load on each panel under both utility and generator power. Now let's get into more detail. First, perform a comprehensive load calculation. This is a critical step to determine the actual load on each panel and to ensure that the generator can adequately supply the essential loads during a power outage. Include all continuous and non-continuous loads, and apply appropriate demand factors as permitted by the NEC. For example, lighting loads may have a demand factor of 100%, while receptacle circuits may have a demand factor of 50% or less, depending on the application. For air conditioning units, use the nameplate ratings for the compressor and fan motors. Add all of these loads together to get a total load for each panel. Second, determine the generator size requirements. The 25 kilowatt generator can supply approximately 104 amps at 240 volts. Make sure this capacity is sufficient to cover the essential loads you want to power during an outage. These loads typically include lighting, refrigeration, heating, and critical appliances. If the total load exceeds 104 amps, you will need to prioritize which loads to power or consider a larger generator. Third, address the transfer switch configuration. The transfer switch is essential for safely switching between utility power and generator power. It prevents backfeeding the utility grid, which can be dangerous and illegal. The transfer switch can be either manual or automatic. A manual transfer switch requires you to manually switch between utility and generator power, while an automatic transfer switch automatically switches to generator power when a power outage is detected. Given the limited space, a compact transfer switch may be necessary. Ensure the transfer switch is rated for the voltage and amperage of the generator and the panel to which it will be connected. Fourth, explore the panel modification. Removing the 200 amp breaker from one panel and feeding it through the 125 amp disconnect from the generator requires careful planning. The intent is to protect the panel with the 125 amp breaker and the generator and the 125 amp disconnects. This is acceptable as long as the conductors from the 125 amp disconnect to the panel's main lugs are appropriately sized for 125 amps according to NEC Table 310.16 and the panel's short circuit current rating is adequate. Fifth, review conductor sizing. According to NEC Table 310.16, for example, using 75 degrees Celsius rated conductors, you would need number 1 American wire gauge or AUG copper conductors or 1/0 AWG aluminum conductors for a 125 amp circuit. Ensure that the conductors are properly insulated and protected from physical damage. Sixth, handle overcurrent protection. The 125 amp breaker on the generator and the 125 amp disconnect serve as overcurrent protection for the panel. These breakers should be properly sized and coordinated to protect the conductors and equipment from overloads and short circuits. The generator breaker should be a thermal magnetic breaker which provides both overload and short circuit protection. The disconnect should also be rated for interrupting the available fault current at that location. Seventh, plan load balancing. Moving the air conditioning units to the other panel helps balance the load between the two panels. This is important to prevent overloading either panel or the generator. Conduct a thorough load analysis to determine the new load on each panel and ensure that neither exceeds the panel's rating or the capacity of the respective feed. Eighth, consider grounding. The generator should have a dedicated grounding electrode system as required by the NEC. This typically involves driving a ground rod into the earth near the generator and connecting it to the generator's grounding terminal with a suitable grounding conductor. The generator's grounding system should be separate from the building's grounding system, except for a connection at the service entrance. Ninth, review the bonding. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that overcurrent protective devices will trip quickly in the event of a fault. All metal enclosures such as panels, junction boxes, and conduit should be properly bonded together. 10th, address the short circuit current rating. The panel's short circuit current rating, or SCCR, is the maximum fault current that the panel can safely withstand. This rating must be higher than the available fault current at the service. The generator's output impedance will typically limit the fault current, but it's still important to verify the available fault current and ensure that the panel's SCCR is adequate. 11th, implement safety precautions. Safety is paramount when working with electrical systems. Always disconnect power before working on any electrical equipment. Use properly insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical systems, consult a qualified electrician. 12th, review NEC compliance. The entire installation must comply with the NEC and local electrical codes. This includes requirements for conductor sizing, overcurrent protection, grounding, bonding, and wiring methods. Consult the latest edition of the NEC for specific requirements. 13. Test the system thoroughly. After completing the installation, thoroughly test the system to ensure it functions correctly and safely. This includes testing the transfer switch, the generator's output voltage and frequency, and the load on each panel under both utility and generator power. Use a multimeter to verify voltages and currents. Use a clamp on ammeter to measure the current on each conductor. 14th, ensure proper ventilation. Generators produce exhaust fumes that contain carbon monoxide, which is a deadly gas. Ensure that the generator is located in a well-ventilated area and that exhaust fumes are vented away from buildings and occupied spaces. Install carbon monoxide detectors in the building to provide early warning of dangerous carbon monoxide levels. 15th, provide regular maintenance. Generators require regular maintenance to ensure they operate reliably when needed. Follow the manufacturer's recommendations for maintenance, which typically includes changing the oil, air filter, and spark plugs. Also, inspect the generator for any signs of damage or wear and tear. 16th, comply with permitting and inspections. Depending on local regulations, you may need to obtain permits and inspections for the generator installation. Contact your local building department to determine the requirements in your area. 17th, document the installation. Keep a record of the generator installation, including wiring diagrams, load calculations, and inspection reports. This documentation will be helpful for future maintenance and troubleshooting. 18th, consider noise levels. Generators can be noisy, which can be a nuisance to neighbors. Consider the noise levels of the generator and take steps to minimize noise pollution, such as installing a sound enclosure or locating the generator away from property lines. 19th, ensure fuel storage. If the generator is powered by gasoline or diesel fuel, ensure that the fuel is stored safely and securely. Follow all applicable regulations for fuel storage, including requirements for containers, venting, and spill containment. 20th, address surge protection. Consider installing surge protection devices, or SPDs, at the service entrance and at the generator to protect sensitive electronic equipment from voltage surges. SPD can help to prevent damage to computers, televisions, and other electronic devices. This should be a comprehensive guide to safely integrating a 25 kilowatt generator into a system with parallel feeds. Remember to prioritize safety and compliance with electrical codes. If you have any doubts or concerns, consult a qualified electrician. Finally, it's crucial to reiterate the importance of safety throughout this process. Working with electrical systems can be dangerous, and it's essential to take all necessary precautions to protect yourself and others. Always disconnect power before working on any electrical equipment, use properly insulated tools, and wear appropriate personal protective equipment. If you are not comfortable working with electrical systems, consult a qualified electrician. They will be able to assess the situation, provide expert guidance, and perform the installation safely and correctly. Furthermore, remember to consult with local building officials and obtain any necessary permits before starting the installation. This will ensure that the installation meets all applicable codes and regulations. By following these steps and taking all necessary precautions, you can safely and effectively integrate a generator into your electrical system and provide reliable backup power during outages. Always double-check with your local regulations to make sure all work is up to local code.